So nice to meet you all. My name is Christophe Bornet, and I work at a company named Data Stacks, which is an AI company. It's mostly known for being the biggest contributor of Apache Cassandra. And we are also developing a database which has vector support. And the vector support is very important in AI, so this is why this database called AstraDB is quite popular. And I've been working with a lot of frameworks in AI in Python, like LangChain. And recently I work on another open source project called LangFlow, which is a visual tool to create AI applications. So my talk is about how to query structured data with a LangChain AI agent. Who has never used ChatGPT? Never used? Okay, so yeah, we all know ChatGPT, and we all know that it can answer all kinds of questions on unstructured data. So there are a lot of techniques that we call RAG techniques, where you can, when you select documents from your sources, and you pass them to your LLM, like ChatGPT, and you get an answer on what you want to do. But first, how do you do with structured data? If your data is inside a SQL database, for instance, an LLM doesn't know how to interact directly with a database. But what you can do with ChatGPT, for instance, the model has been trained on all the internet documents, and it has been trained on a lot of SQL queries. So it knows SQL. So you can ask a query to ChatGPT. I have a table. The table has this schema, and you ask your question, and ChatGPT will answer with a correct SQL most of the time. So what we can do is have this kind of chain. We have our question. We extract our database schema. We assemble them in the prompt as the LLM, and the LLM returns a SQL query. Then we execute the query. We get the data from the database. And we use this data together with a question. We ask again the LLM. This time we have the data from the database that we want, and we can get the correct answer. So now what I want to show is how to do it with code with Python. So this is a notebook I will use. So I have installed some packages, LangChain OpenAI, to deal with OpenAI as my LLM, and AstraDB, this is a vector store. I will show why a vector store can be useful later. So I have already entered some credentials. And this is the SQL database that I will use. So it's a SQLite database. There are some tables. So there is a student table. A student has an ID, a first name, last name, an age, a sex, etc. Okay, we have some students that we put inside our database. One is named John Wick. He's a bit old to be a student, but never mind. There is another table named pet. A pet has an ID. It has a type. It can be any type of type. So we have cat, dog. Some pets are there, and there is a many-to-many relationship between pets and students, which is called hasPet. And hasPet, we have some here values. I have added one, which is a relationship between John Wick and a dog. Okay. And so we can, okay, let's seed our database. Okay. Now I want to do the things I've done manually, but using Python code. One library we use a lot in Python is SQL Alchemy. So SQL Alchemy, this time I start again from scratch. I connect to my database, and SQL Alchemy can reflect the schema of a database using this construct, metadata.reflect. Okay, the metadata has been reflected. It's in a SQL Alchemy object. But what I want to pass to my LLM is a string. Fortunately, it's easy with SQL Alchemy to do it because you can just pass string create table of your table. So you get all tables from your metadata. And you join this with some backslashes. And if you execute it, you get the schema, the statements to create the schema. So this is, we are starting to build our prompt. We can have some kind of template like this. I have my question. I have an instruction I want to give to the LLM. So you're a SQLite expert. You need to create the query correctly, etc., etc. So this one I took from, I just copy pasted it from LangChain. And then I say you can use the following tables, and I put my create table, etc. Okay, and now I have a prompt which has been generated with code. Okay, so now I want to show how I will do it using LangChain. So what is LangChain? LangChain is a framework written in Python. It's the most popular framework for building AI application. It has more than 90,000 stars on GitHub. And so as a framework, the goal is to put together some pieces so it has the possibility to integrate LLMs, so models for text analysis, etc., embeddings, so OpenAI, the most popular ones. It can work with vector stores, so vector stores are used a lot in RAG. Document loaders, so for unstructured data, so this is not interesting for this talk, but there's a lot of way you can source documents in LangChain. And then some built-in pieces inside LangChain, so prompt templates. You've seen that we were using a kind of template before, so this will be useful. Text splitters are more for RAG also, because you need to have documents that are not too big for your context window in the LLM. Chains, so this is the way you build an application in LangChain, assembling components that are called in a chain. And agents. Agents is the most evolved way of doing of creating applications. This is what we will see later in this talk. Okay, so now let's do it again, but using LangChain. So in LangChain, there is a component called Chat OpenAI that I can use to interact with OpenAI, and I have passed it the prompt that we built before. Okay, and we see that OpenAI responds with this query, which seems quite good. So my question was, what type of pets does John Wick have? And the answer is, I'm doing the join on student has pet and pets, and I'm filtering on student first name John and last name Wick. Okay, so next step, we are going to do the first things we did manually, getting the schema from SQL Alchemy. Actually, LangChain has a component which is called SQL database, and it integrates SQL Alchemy, and it does it so you have the same thing we've done before, but with a component which is done, integrated in LangChain. So I can do the same. I connect to my DB with a SQL database, and I can see that I can get the table info the same way that we did before. Okay, so next step, we want to create a chain. LangChain is about chain, so there are some constructs that are already existing. We can see that it's quite easy to do a SQL chain in LangChain. So I just add my LLM, which was the chat OpenAI, and my DB, create SQL chain. And I can explore what the prompt will look like. So I said that I had copied before the prompt from LangChain. So here we can see the prompt from LangChain. You are a SQL expert, etc. It gives a format to explain how to the LLM how it will provide the question, how it wants the LLM to answer. There's a placeholder for table info, so this will be used in runtime, and there's a placeholder for the input. And now this is how we call the chain. So just chain.invoke the question. So the question will go into the input, and the table info will be fetched from the SQL database component that we've put before. Okay, I've put some debugging, so it's not so easy to check debugging, but I will try to do it anyway because I do not have another way. So we see that table info was fetched from the database, and this is what was sent to the LLM, so the question, etc., etc., etc. Okay, here only use the following tables. It has replaced the table info placeholder by the create table statements. And at the end, we have the question, what type of pets does John Wick have? So this is what has been sent to OpenAI. And OpenAI, at the end, answered. Okay, it answered SQL query, select pets, .pets type, etc., etc. So this is good. One thing we need to understand about LLMs is that the more you provide information to the LLM, the better the answers are. And a way to provide, to have more accurate answers, because here I'm lucky, the query is quite simple and the LLM answered correctly, but a lot of time it hallucinates. So a good way to improve the quality of my prompt is to add some examples. And to add some examples, I will use that data set which is called Spider. And Spider, actually, the schema, the database schema I've taken is from Spider. And Spider it's a data set that has that does a correspondence between golden sample queries and golden sample questions and queries for the schema. So, for instance, if it was your own database, probably you would have to build this base of correct input and queries. You could do it by validating generated queries by the LLM and say, okay, this is the correct query, etc., etc. So here there are 1,000 examples in the data set. I'm only printing the 10 first ones, which are about singer, but later in the data set there are some about pets, students, etc. Okay, but now I have all these queries, and I cannot put them all inside my prompt. It would be too big, probably, because the context window is limited in the LLM. So what I will do, this is where I will use a vector store. So if I had time, I will explain in details what a vector store is, but I need to be short. So a vector store, in a vector store, you index some content together with an embedding. And an embedding, so it's actually the vector, is a representation of this text given its meaning. And the interesting thing with the vector store is that you store a lot of examples in your vector store, and then you compute the embedding for the question you ask, and you can do a similarity search between the question and the examples you have. So for instance, in LangChain, there is a component called semantic similarity example selector. I will feed it with the examples that we have before. I'm putting an embeddings model, so using OpenAI embeddings. My vector store will be AstraDB because this is the best vector store in the world. I've already put the token, application token and endpoint. And so this component, so I'm loading the vector store with the examples. And the interest of this component is that now I can do, I can compute the embedding on my question and get all the examples that will be about the same subject as the examples I have in my vector store. So let's see, for instance, I still take the same question. What type of pets does John Wick have? And let's see what kind of examples I get. Okay, so now I have 5 example queries that are about pets, that are about students, and what type of pet they have, etc. So probably these examples are quite close to the question I have asked. And what I can do next, so here there's a little bit of code, but I can create a few short prompt templates. So this is a construct in a LangChain, where I will put the SQLite prompt. So this is the same as the prompt before. I say I will put some examples. Examples will be formatted like this, so input and query. That's a fix. I provide the example selector, okay? And I do it again, create the SQL query chain. This time I override the default prompt with my few short prompt. And we can check how the prompt looks like. Okay, so same beginning, except that now there is this, okay, SQL queries. At the moment, it's static. I haven't run it on my query. So the examples it gets are not related. Probably they are similar to the empty string. Okay, and then there will be the table info and question. And I can invoke again the chain. Okay, so we can check what has been sent to the LLM. Okay, same beginning of the query, and at some point, okay, here are some example of user input and the corresponding SQL queries, and it's how many different pets are there. Select distinct pet types. So the examples that were provided to the LLMs are quite similar to my query, and so. This helps get better results. So I have here, I don't know if the query is correct, but anyway. We could continue. So now we've been able to run with LangChain to generate the SQL query. We could continue to use LangChain to execute the query, to get the result, to send the result to the LLM like I showed in the introduction. But one thing interesting is to do it with an agent. So what is an agent? An agent is a kind of autonomous system that will use an LLM to take decisions. And it will tell to the LLM, I have some tools at my disposition, and which tool should I use to continue to solve the problem. So the agent says to the LLM, basically, you can use the following tools. I have already executed these tools with these results, and you need to tell me what to do next. Can you answer the question, or should I execute one of the tools? So there are a lot of tools available in LangChain. The one that will be interesting for our use case with SQL is the SQL Database Toolkit. The SQL Database Toolkit, so it's a bundle of tools where you have list SQL, database tool, info, query, and SQL checker. So the list SQL database tool will return all the available tables in the database. Info is used to get the schema for given tables. Query SQL is used to execute the query on the database and get the result. And the SQL checker, it doesn't use a database, but it uses a LLM to check a query. So you provide it a query, and it tells you, yes, it's a good query, or no, it's not a good query. Oh, not yet. Okay. So let's create now an agent. So yeah, I talked about the SQL Database Toolkit. We can check what the tools look like. So there are the full 4 tools I talked about before. Each tool has a name. So this is by the name that the LLM will reference which tool it wants to use, so SQL DB query. And each tool has a description. The description is important because this is what it is what the LLM will get to understand what each tool does. And it contains information also about how to call the tool, what are the arguments, etc. we can create the SQL agent, very simple. I just import creates SQL agent. I still use my LLM OpenAI. I still use my DB SQL DB database component. And we can check what the prompt looks like. So a little different than before. We are telling you are an agent and you need to execute the query. You have these tools at your disposition, so only use the tools the below tools. This is where we get the tools that were put into our toolkit. So you have a SQL DB query, you have a SQL DB schema, listables, query checker. And we also say to the LLM, here is the format we will use to communicate. So you will tell me what action I will do, with what arguments, and I will answer what is in observation. I will tell what is the result of the action. Okay, so now we can execute our agent. Oh no, important thing before. At the end of the prompt, there is the agent scratchpad. So this is where at each turn, we always send the same prompt and we add things to the scratchpad. So in the scratchpad, you will have the action input, and the observation for each step. Okay, we execute the agent. And, okay. It's going too fast. Okay, so I'm sending the question to the LLM. Okay, the LLM answers with action SQL DB listable input is empty. Okay, so now I execute, the agent does it all by itself. It says, okay, you have this table, aspect, pest, students. Okay, you put it into your scratchpad, list table, okay, you get that. And we call again the LLM. This time we put the prompt, and at the end, so it's a bit long. Okay, at the end of the prompt, we have said, okay, listable, we have already done listable with the input, and the result was aspect, pest, students. Okay, now what, go back. Okay, so the LLM says it seems like aspect and pest tables should be relevant. I want to get the schema. Oh, interesting. Probably student, it should have fetched also student, but it didn't think it would be needed at the beginning. Okay, so my tool SQL DB schema returns the schema for the pets. Put them into Scratchpad, add them to the LLM prompt, and prompt the LLM. Okay, the LLM answers, okay, I have information about pets as pets, but I also need the student table. Okay. Now get me also the schema for the student. So we see that if we had coded this manually, probably we would have gotten all the tables we needed from scratch. But there, the LLM shows which table to get and did it iteratively. Okay, we pass the student table. We put the student table into the scratchpad, so it's added to the former steps, and we call the LLM again. Okay, we have information, etc. Okay, I need to check. I think this SQL query should be good. You need to check it. Okay, select byte, etc. I will, the agent continues by calling the SQL DB query checker. Okay, it says that, oh yeah, it calls an LLM to check. This is why there is an LLM. We have the result. It says okay, because it returns, when it's the SQL is correct, it returns the SQL it got. Then we send again everything to the LLM. Okay, the LLM says the query is correct and it can be executed. So we need to SQL DB query, so do the query and get with the request. We execute the query. Oh, okay, there's a problem, there's an error, because this was sent by the LLM. Okay, we do another turn, send back to the LLM. Okay, the LLM sees that the format was there was some mistake in the format, so it will try again. Okay, error again. Okay, I hope that at one point it will get the. Okay, it says, okay, I have done a mistake. Trying again. Okay, this time the LLM returned me a correct SQL. Okay, we can see. Oh, wow. What happened? Okay, this time the SQL was correct, and I get a result dog. Okay, last time we sent to the LLM. This time the LLM says, okay, I know the final answer, John Wick as a pet, as a dog. Okay, this is final answer, John Wick as a dog. Okay, and this is the output of the agent, John Wick as a dog. Going quickly because I do not have a lot of time. We can also do it with few shot prompt. So this is how you would do it. It's a bit complex, so I'm skipping this part. The only thing to note is that here I'm writing some code to add the few shot prompts. I think it shouldn't be done like this. We are using an agent, so we should have a tool to be able to get some examples. But this is for later. This is something that should be developed, and I think I will probably develop it because it's an interesting subject. Okay, last thing I want to show quickly, it's LangFlow. LangFlow, it's a visual tool which is based on LangChain, and the interest is that everything I've shown you with code, you can do it with a low-code approach. So here in LangFlow, I have the SQL agent from LangChain, so there are a lot of components from LangChain. I can put an LLM, so here OpenAI, I've put my OpenAI key. I put a chat input and chat output, and the interesting is that now there's a playground. What type of pets does John Wick have? Okay. And so it's using the SQL agent from LangChain. We can see that it's executing the steps. So doing several times, asking for the schema. Okay, doing the query. Okay. Okay, and John Wick as a dog. Interesting thing is that I can explore what has been done by LangFlow. So the same thing I've shown before in my notebook. You can have some input here. Yeah. So LangFlow is useful if you're not a developer or if you want to quickly prototype things or start new applications, AI applications. Very quickly, some additional considerations. You remember the talk before. Security is very important, and LLMs you can put you can inject things into LLM and make them answer crazy things. So be very mindful about what you authorize, especially when you execute the query on the database. If the answer from the LLM is drop the user table, it's really not something you want to authorize the LLM to do. So use their back, only use views, etc. Performance, if you have high cardinalities, it's something to be aware of. You could put pressure on the database if the query is one that takes a lot of time. And quality, never expect the LLM to answer always correctly. They hallucinate a lot. There are a lot of stories on the internet of LLMs going bad. Okay, so thank you very much. This is the end of my talk. You have some links for LangChain, LangFlow, AstraDB, and if you want to reach me on Twitter, this is my Twitter handle.
Thank you. I think we have time for one question. Does anyone have something that they want to ask?
Wow, everything was so clear.
Well, yeah, everything was super clear. I guess you can approach afterwards. And thank you so much.
Thank you very much.